Hello madam, this is internship on IoT based home automation solutions, and this video lecture is submitted in partial fulfillment of the requirements for the award of internship in Internet of Things, and this is submitted by Ropangudu Ritesh Babu, me and my partners Sheikh Abdul Fahim and PVN Appalnaidu. And as we go front, during this course of internship, in 5 weeks, we have learned 5 topics, which covers in first week C programming, and in the second week project requirements and designing, and in the third week building the units peripheral programming, and fourth week project integration and testing, and finally in fourth week we have attended this workshop. Topics covered in C programming. While learning the C programming through Emertxe information technologies, we have learned introduction to C and data types, conditional constructs and operators, arrays, functions and pointers, and then recursion constant qualifiers, strings, string operations and storage classes, preprocessor and utilities, and then finally introduction to C++ class, object creation, constructor and destructors. As we go forward, in the second week we have learned about project requirements and designing and Arduino programming. In this we have introduced to IoT and learn about a project IoT based home automation solutions, requirements for it and its explanation. And then we have learned how to install PiximLab and Arduino IDE, null emulator, etc. And here we are introduced with embedded systems, an introduction to Arduino IDE, and overview of PiximLab LED programming. In the third week, we have learned building the units, that is peripheral programming. In this, we are introduced with CLCD programming and analog to digital converter, temperature sensor and PWM module working and its explanation, and learned controlling LED using LDR, light dependent resistor. In the fourth week, we have learned integration of project and its testing. In this, we have used Blink. They have showed how to configure Blink app and controlling heater, cooler, and reading temperatures using Blink and displaying the notifications on CLCD. And then finally learned configuration of serial tank. Our main motto of this internship is there are 3 requirements, in which the first one is to control brightness of garden lights using light dependent resistor sensor and Blink IoT mobile application. And second requirement is to control the room temperature using temperature sensor, that is LM35 and Blink IoT. And third requirement is measuring and controlling volume of water in water tank using serial tank and Blink IoT. And then let us see how the requirements and how we control garden lights. We control the garden lights using LDR sensor. First of all, we see what is LDR sensor is. It is nothing but a component that has variable resistance that changes with the intensity of light that fall upon it. LDR means light dependent resistor. Based on the resistance values, based on the light values, the resistance values changes in it. And then LDRs are often used in circuits where it is necessary to detect presence of level of light. And this is the block diagram which describes about how Arduino is interfacing with LDR sensor and lights. In this, LDR sensor is interfaced with Arduino Uno and it outputs through lights. The output of LDR is given to analog digital converter, which is present in Arduino. When it is less light, there is more resistance and less voltage. If there is more light, then there is less resistance and more voltage. Output of ADC ranges from 0 to 1023 values. Vout output voltage is equal to 0 for less light. Then the brightness of the garden light should be more. If Vout is equal to 1023, that is a high value for more light, then the brightness of garden light should be less. Now we shall see how to convert output voltages of ADC to brightness of LED. Brightness of output LED is more and the input value is high, where analog to digital converter output or natural light is very less. Brightness of output LED is less and the input value is low, where analog to digital converter output or natural light is very more. When output of ADC is 0, then output of ADC values ranges from 0 to 1023 and input voltage to LEDs 255 to 0. Here we use some formulas for the conversion. Input value is equal to analog read of analog LDR. It is used to read and store LDR sensor values using analog to digital converter. Input value is equal to input value divided by 4. It changes the range from 0 to 123 to 0 to 255 values. Input value is equal to 255 minus input value. It converts high ADC values into low input voltage of LED and vice versa. Let's see how it works. When the natural light is very low, we will get low output voltages from analog to digital converter, that is ADC. And by using the conversion formula, we are providing more voltage to output LED. Suppose ADC output value is equal to 0, then we get input value is equal to 0 divided by 4 equal to 0. Then the final input value is equal to 255 minus 0 is equal to 255. That is high value. And in the second case, when the natural light is very more, we will get high output voltages from ADC. And by using the conversion formula, we are providing more voltage to output LED. Suppose ADC output is equal to 1023, input value is equal to 1023 divided by 4, which is approximately equal to 255. Now the final input value is equal to 255 minus input value, that is 255 minus 255 equal to 0. We get Vin is equal to 0, that is low value. By using these methods which are discussed above, we are controlling the brightness of the guardian lights according to the amount of presence of light. Let's see in this figure how the output changes based on the resistance values. In the first figure, if you see, the resistance value is low. That's why the light is very low. And in the second case and third case, if you see, the resistance values are increasing. As the resistance values are increasing, the amount of light is also increasing. By using the above, we have discussed how to operate our requirements. Okay, now let's see the coding and see how it works in the Arduino. And this is the coding part for our first requirement of controlling the brightness of the guardian lights. In this coding program, we see first we have used formulas to convert from analog to digital, because from the LDR sensor we get analog values, and using this coding we convert them into the digital values. That is, by using input value equal to analog read of LDR sensor, and input value is equal to input value by 4, and then finally input value is equal to 255 minus input value. By using this, we control the brightness of the LED based on the natural light. Let's see how it works by using Arduino simulator. Now let's see. First of all, we see when the resistance value is low and the light is not low. As we slowly increasing the value, the brightness of the LED is also changing. From this, we can see that as the resistance values are changing, the LED is also glowing low and high. That is, the intensity of the LED is changing. From this, the first requirement is accomplished, and we go through second requirement.
Hello madam, I am PVN Appal Naidu from Adjugative Ongol. I am here to explain about temperature control system as a part of our IoT internship. And this is our second requirement. We will fulfill this requirement by using CLCD, Arduino board and control the heater and controls the cooler switch by using Blink IoT also. First of all, what is temperature control system? The temperature control system consists of heating resistor, an LM35 temperature sensor and a cooler, which resembles the temperature control system at home. We will read the temperature from the temperature sensor LM35 and display it on the CLCD. And control the temperature. We will control the temperature of the system by turning on and or turning off our heater and cooler by using our mobile application Blink IoT. By using Blink IoT, we will status of the control the status of the heater and cooler as our requirement. And this is the block diagram how we implement our temperature control system. First of all, we use a temperature system LM35 sensor and temperature system we will read temperature from the temperature system and we will provide it to our Arduino board, and again the temperature will display on our mobile configuration Blink IoT, and we also able to give commands of heater and cooler from our application through Arduino, and that will be applied to our temperature system. And as well as these the status of the heater and cooler are also displayed on the CLCD, like heater is on, heater is off, like that. And whether the heater is increased room temperature above 35 degrees, automatically the cooler switch will on and heater switch will turn off, and we will get a notification for our Blink IoT app. First of all, about LM35 temperature sensor. LM35 series are precision integrated circuit temperature devices with an output voltage linearly proportional to the centigrade temperature. LM35 sensor uses the basic principle of a diode, whereas the temperature increases, the voltage across diode increases at a known rate. And centigrade temperature, if we increase it 10 degrees, 1 mil voltage read, okay, sorry, centigrade temperature equals to voltage read by ADC by 10 millivolts. We'll get one as we discussed it before. Temperature system will give output of temperature. These temperature values are analog in nature. By using analog ADC, means analog to digital converter, will convert it into digital, and Arduino board containing only one ADC converter, and the pins are A0 to A6 pins we are connecting A0 to A5. The output of reading 1235 is provided to ADC. The outcome voltage of ADC is converted to temperature by using the following formula. Temperature equals to analog read of A0 into float of pi divided by 1023 and divided by float of 0.01. Analog read is the used to read the analog values and provide it as the input to ADC. And syntax of analog read is analog read of pin. Here pin represents the number of analog input pin to read from sensors or channels values. For every 100 microseconds, it reads an analog input. Now, based on the temperature value, it automatically makes cooler and heater on and off respectively and displays the state of the cooler and heater in CLCD. Suppose if temperature of the room is above 35 degrees centigrade, then automatically the system will turn off the heater switch and turns on the cooler switch. Another way, we will also control these by manually by using our mobile application Blink IoT. What is Blink IoT? Blink was designed for the Internet of Things. It can control hardware remotely, it can display sensor data, it can store data, visualize it, and do many other cool things. Create widgets on mobile Blink application. We can create many widgets like button widget, gauge widget, terminal widgets in our mobile applications. We'll see some of widgets. Button widget to control heater, cooler, inlet valve, outlet valve, like that. To turn on the heater or turn off the heater, turning on cooler, like that. Gauge widgets. Gauge widgets is used to display how how much amount of water in cereal tank or how much centigrade in room temperature is to display temperature and volume of the water in the tank on the mobile application as now we discuss it. Terminal widgets to display the notifications whenever threshold is crossed like temperature is more than 35 degrees turning off the heater like that. As we move for when the heater is on, the temperature rises above 35 degrees Celsius, then the heater should turn off automatically as our requirement and message message to Blink IoT like that temperature is more than 35 degrees Celsius and turning off the heater. That should be displayed on the our mobile screen in our Blink IoT configuration and also display on the heater is off on the CLCD. CLCD is nothing but character LCD that is used to display the characters in a device. Arduino board doesn't have any communication and also will communicate with Arduino board by using Ethernet shield. Why means Arduino board doesn't having any Wi-Fi module or any Bluetooth module to communicate with it online or directly. By to communicate with Arduino board, we'll use Ethernet shield. Arduino board doesn't have like that. Arduino board doesn't have any direct communication through online or Wi-Fi. To make communication with Arduino is possible by using only external communication protocols like Ethernet shield. That's why we use it Ethernet shield for this requirement. Here we see this is the required output of our temperature control system. As we see temperature is very high, it is turned off and here temperature is turned not above 35 degrees and heater is turned on and here we see cold there are different states of cold that is turned on and turned off that was displayed on CLCD. And this is the Blink IoT configuration and this is the temperature gauge and this is cooler status of cooler and status of heater and here we are getting the notification that is the temperature is above 35 degrees like that. Until now we discussed what we want to do in temperature control system and what is our requirements and now we'll look at about coding and simulation part. And here we see like temperature system, okay, and we are defining the different modules like cooler, heater, pins and we use it in temperature cooler control system and this is the function for reading temperature from temperature system and again here we go for main code with Blink IoT configuration. First of all, cooler pin, we are controlling cooler pin by using controlling giving commands with param.asInt of if cooler control on and automatically control will display on CLCD like cooler on and set cursor to the position of our requirement our displaying characters at what position it should be displayed and if the cooler is off automatically at the same position only we displaying the status of cooler that is turned off and again like that only heater pin also And here heater, so like if heater is on, that is displayed on the heater, like heater on. Again, heater is turned, if heater is turned off, and that will be displayed on heater off on CLCD. And also will control heater and cooler by using heater control. Here we see handle temperature. When when the temperature will read temperature function will use it to read the temperature from temperature system. And if the temperature is above 35 and also heater switch is being turned on, and if this condition passes through, heater switch is automatically turned off, and that will be displayed on our CLCD, and automatically will send a notification to our blink IoT that is temperature is above 35 degrees Celsius and heater is turned off. And will turning on heater, turning off heater, and turning on cooler automatically. And this is the coding part, and here we see the simulation part. This is Piximlab configuration, and here spare parts. This is CLCD, and we are able to check the status of heater, that is heater is turned off, and displaying the temperature that is 27.37 degrees Celsius. And again, we, as long we discussed that we are also able to control the status of the heater and control by using blink IoT. And here we will see how it was able to do. One minute. Okay, here we configured our Arduino to blink IoT, and here we see temperature in CLC 27.37 degrees and heater is turned off. If we are able to control heater and control cooler from our blink IoT configuration only, and if we turn on heater, here we see the status of heater is displayed on CLCD, and when we are able to see the temperature is rising rapidly, and automatically temperature is increased about 35 degrees Celsius. And here we see that status of the heater is turned off, and automatically temperature is decreasing by turning on the cooler. If we turn on the cooler, and here we see we are displaying cooler status, that is cooler on, and temperature also decreased to 27.37 degrees, and we will turning off our cooler and displaying that status to CLCD. And also we will get a notification that temperature is above 35 degrees Celsius, and we are turning off our heater from CLCD, sorry, from program.
Up to now, my friends have completed two segments of the project. Now I am going to explain the third segment. First of all, thank you for giving this wonderful opportunity. My name is Abdul Fahim. I am from Rajiv Gandhi University of Knowledge and Technologies, IIIT Ongole, Andhra Pradesh. Now I am going to give presentation about our third segment, serial tank configuration. And first, going to requirements of this segment, we should able to turn on the and turn off inlet and outlet valves of the serial tank using mobile. And if the water in the tank is less than 2000 liters, the inlet value should turn on automatically. If water level reaches 3000 liters, the inlet valve should turn off automatically. If it is if and only if it is in on state. And at every command should be displayed in the CLCD and virtual terminal in the blink app. And going to the project, we need to read the volume of the water in the tank through serial communication and display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and outlet value by sending commands through serial communication. Display the volume of the water in the tank on the CLCD and also have control on it. Going to next slide. This is the block diagram of the segment, in which we can see the inputs and outputs of the different devices. The volume of the water is decreases if the outlet value is turned on. Display outlet value is turned on the CLCD. If the volume of the water is below 2000 liters, the inlet value turns on automatically and sends a message water level less than 2000 liters, and the inlet value is turned on the and will be displayed on the virtual terminal as a notification in the Blink mobile application, and displays inlet value is on the CLCD. When the water in the tank is full, turn off the inlet value automatically. The full means 3000 liters here, and display water level is full, water inflow disabled. And if you see here, controlling serial tank, these diagrams are the screenshots taken from the mobile in the simulation. In the second line, we can see the volume of the water present in the serial tank, and beside it we have the commands, that is outflow off, outflow on, inflow off. As you are seeing in the third diagram, third picture, that if the volume is 3000, volume of the water serial tank is 3000, and hence inflow is turned off. And this is the mobile app configuration, that is, in mobile we will have two buttons, that is inlet valve and outlet valve, and a volume meter which will show us the how much liters of water present in the serial tank right now. And here in the below there, that is a virtual terminal in which the commands will be displayed, that means the notification is displayed according to our inputs and the automatic values. And now let me show you the uh, simulation and the coding part of the third segment. If you go to the code, in the serial tank segment, we are going to use these methods. Those are initializing serial tank. It's a common method for every configuration, and enable inlet and enable outlets are the two methods which are used to turn on the inlet valve and outlet value, and disable inlet and disable outlet are the methods used to turn off the inlet value and the outlet value of the serial tank. And this volume method will display the volume of the serial tank, water contained in the serial tank. And going to the main function, main program, here handling of the tank. Here, if the tank volume is less than 2000 and the inlet switch is off state, then we need to turn on the inlet value so that the water will go to the serial tank, and which is our requirement. And the other and the command should be displayed on the Blink terminal and also on the CLCD. And if the tank volume is 3000 and the inlet switch is an on state, that means the serial tank is in the highest capacity, so that we need to turn off the inlet switch, so that we are using the inlet switch is off, that is disable inlet off method. And display that commands in the CLCD and notification in the CLCD and also on the virtual terminal. And if you go to this simulation, yeah, this is our serial tank right now. Yeah, I will show you my mobile so that you will see the volume of the water. In our tab 2 we are configured our serial tank. Right now the water volume is 2620 liters. If we turn on the inlet value, the water will increase. And if you see, as the water flow is reached 3000, we have got the virtual terminal is reloaded. And now see, if you see, the inlet values, the water volume reached 3000, and hence that will be disabled in the inlet value is disabled, and the notification is sent into the virtual terminal of the Blink app, and also in CLCD. Let me show you. You see here, inlet value is off and the volume of the water is 3000 liters. And if we turn on the outlet value, so that water will be drained out. At the point of 2000 liters, as it reaches the minimum point of the serial tank, the inlet valve will be turned on, and this will be notified in the virtual terminal of the blink app also. See, water flow is less than 2000, inlet value is enabled. Water flow is equals to 3000 means if after that we have to turn on the inlet value, right? So that the water level is full and the inlet value is disabled. And above commands also displayed on the CLCD also. And finally, the new skills we have learned in this internship is C programming, introduction to C++, introduction to IoT, introduction to embedded systems, and we are familiar with the tools like tools used in the IoT and Arduino programming, and we learned about Blink app configuration and also installation of Pixim Lab, Arduino IDE, Null modem emulator, which are used to simulate our project, and Arduino Uno drive in the Pixim lab, etc. And we learned about LCD module, ADC module, PWM module, persuasive modulation module, and the serial communication concept. And by this project, we learned controlling of devices using Blink app through Blink Cloud Server, IoT based project. And finally, our conclusion, the internship at the emerging industries helped us in learning various new skills such as C, C++, IoT, Arduino programming, etc. Through this internship, we learned home automation like controlling brightness of the light, temperature control, and the volume of the water in the water tank, which are used to decrease the power misusing and develops effective usability. It was very good experience for us to work in MSc, which helped us to work on real-time problems using IoT. And finally, thank you for giving this golden opportunity. Thank you.